Okay, we are going to work on homework 4, question number 1. So, what do we have? For x bar is a mean for the sample, okay? Sigma is 22, n is 33, construct 99% confidence interval. Estimate confidence interval estimate of the population mean. So first of all, let me explain to you what is confidence interval real quick. Um, Confidence interval when I claim that average mean is gonna be within this interval, because for example, if you are distributing, let's say, some product, right? uh, you can't, if it's by the large amount, some the tons, let's say, then you won't be able to talk about average, but you can say that the average is somewhere between, let's say, 150 and 170. Okay, so here we've given us information, the average of the sample, x bar meaning average of the sample, and sigma is a standard deviation, and n is 33. We need to construct confidence interval. So meaning figure it out with 99% confidence, because you can claim that that, let's say, the average of the population is within 90% confidence interval. The mean of the population within 99% confidence interval. So the higher confidence interval, the narrower it's gonna be your interval. If you want to grab a greater the interval, then you have to lower your confidence interval. Okay, so let's see how we're gonna calculate and what we're gonna do. So there is the calculator, and I'm going to put the link of this calculator in the under the video, and where the comments are, and pin it so you can see. If you are looking on this video on your cell phone, then you have to drop down. There is to see that pinned the link to the calculator. You have to drop down that comment so you can see it. Okay, but on the laptop or desktop it will clearly show right away. So all this information, the average of the sample, standard deviation, and sample size, I'm going to put the information right here, and the link to this formula, like I said, I'm going to put right under video. So we have sample size is 33. We have sample mean, I had there 119, 119, and I had standard deviation, how much was 22. And we need a 99% confidence interval, so I placed it here, calculate, and we are getting 109.135 and 128.865. So let's go back. 109.12. So 135 if you round. Oh, well, it's a matter here. We have a little bit difference. And 128.88. Okay, we are getting here a little bit difference here. Let me do on calculator. Let's see, here it's given, see, 119 is average, and then plus minus 9.865. This 9.865, that's our error, because you can't precisely foresee the average, so you always allow some error. So let's see. 119 plus 9.865, and I'm getting 128,865. Okay, and here is 128,88. Well, that's interesting. Even if you round up, you get 8687, not 88. Guys, I tried the calculation on different calculator, and I still got exactly same result. The one we got here, 109, and hold on, well, let me see, this one, 100, yeah, 109 and 135, so 14 and 128.87, so which means this the rounding is somehow it's different. I don't know how. I would be curious to find out myself, but what I recommend, obviously once you put the result, it's gonna catch as an error. So text me, send me text message, and I'll give you credit back for such an answer. Okay, I just double check with several cases, and it doesn't matter. It's giving me different answer. I mean, slightly different, of course. All right, moving to next question, question number 2. Let's see what we have here. What problem we are going to solve. So a bottled water distributor wants to estimate the amount of water contained in 1 gallon bottle that was purchased from a nationally known water bottling company. The water bottling company specification states that the standard deviation of the bottle hold on, lost it. That the standard deviation of the amount of water is equal 0.01 gallon. Okay, let me take the picture of this question so I can take out the data. Yes, 0.01 gallon. A random sample of 50 bottles is selected, and the sample mean amount of water per 1 gallon is 0.997 gallon. So complete part A through B. So one more time, let's read now carefully. So I'm reading for the second problem, second sentence, that the water bottling company's specifications state that the standard deviation of the water is 0.01, okay, gallon. A random sample of 50 bottles is selected, and the sample mean amount of water per 1 gallon bottle is 0.997. Okay, so before we start working on this problem, I'm going to write down the data. So the ones we have it. So what do we have? We have standard deviation, which is sigma. We have 0.01. Okay, a random sample of 50 bottles. So sample of it's a n, total amount is 50 bottles selected. All right, and the sample mean x bar is 0.997. So because the sample mean amount of water per 1 gallon bottle is 0.997. Okay, let's read further. So complete parts A through B. Construct 95% confidence interval estimate for population mean amount of water included in first gallon in 1 gallon bottle. All right, let's see what we can do. It says construct with 95% confidence. Confidence is 95%. Let me put L, confidence level. All right, so how we are going to solve this problem, because we have not 1 bottles but 50 bottles, so we're going to use the formula that gives us x bar plus minus z alpha half. I will explain alpha half. Actually, I will refresh your memory because you have learned it in basic statistics, square root n. So we need to find out to construct 95% confidence interval estimate for the population mean amount of water that includes 1 gallon bottle. So confidence interval consists of average of the sample or population, okay, plus minus margin of error. So this piece, this is margin of error, okay, and this is our average. So we need to calculate, plug the data, and we will get a result. How we are going to do it? So let's calculate. For confidence interval, I'm going to plug this number, the data I have, into calculator for confidence interval. I have it. Let me see. Confidence interval. Here we go. So let's plug it. So I had how much? Sigma 001 and 50. Sigma is our standard deviation, 0.01, and sample size is 50, and sample mean was how much? 0.997, right? I believe so. 0.997, correct. And confidence interval, we want 95. Let's calculate, let's get what we got. So we got 0.994 up to 1, and here we got 0.994 up to 9997. Okay, here is this is rounded 1, 0.997, and you need to put in the decimal notations. Okay, we are going to face this problem everywhere, looks like. I need to figure out what to do, otherwise I have to give you credit for this one also. If we plug it here, this confidence interval, it's gonna go same thing, I believe. Yeah, because here look what's doing. It's rounding till 3 digits, so 0.994, and here we have 99423, and here we have upper level, we have 1.000. Here we have 0.99977. Well, I guess we have no choice. You put the answer, and I'll see that you are close. So because they want 1, 2, 3, 4 decimal, and we have there 2 or 3 decimals. So I'll see that your number is correct. It's only 3 decimals, not 5, and I'll give you credit. It seems to me this homework will have a lot of problem, because I was going through and I caught another problem here also. But that's all right. As long as I can explain to you and you understand, that's all does matter. So on this, let's do B. On the basis of these results, do you think that distributor has right to complain to the water bottling company? Okay, how are we going to identify if it's right to complain or not? So if the average, which is claimed here, 0.997, it's right here, so you can see 0.997, falling in the interval of a confidence, which is 0.99423 and 0.99977, then we can't complain, because we got what they claim, right? They claim 997, and it's falling between confidence interval. Then we can't complain. It says yes, here we can complain, because 1 gallon bottle contains exactly 1 gallon of water that lies outside, which is not the case. 997 of gallon laying between here, we have maximum 999. So I'm going to explain that the truth, it's going to be no, because 1 gallon bottle contains exactly 1 gallon of water, lays within 95 confidence interval. But since you see this recording, so you have to put the wrong answer so you can get I apologize. I have no other choice to get the points. Okay? But as we can see, 0.997, it's falling within this interval. Therefore, they have no reason to complain. Next, C. Must you assume that population amount water per bottle is normally distributed? Yes, because we are doing this for normal distribution. Well, the answer is here a silly way. No, because central limit theorem almost ensure that X is normally distributed. Well, which is obviously meaning it's normally distributed. The whole distribution is normal distributed. Okay, but you can see this answer and put the answer the way it's given to you. Sorry about that. Next one. Oh, I noticed that, okay, I need to explain this. Two similar answers. A, no, because central limit theorem almost always ensures that X bar, meaning sample mean, is normally distributed when n is small. Now, and in this case, it says when n is large. Just so you know, what is the central limit theorem we are using for the large sampling, because we're a large sample, like 50, more than 30, it's considered large. Why? Because how can it gonna be, makes no sense to find the average of the entire distribution if the sample is small. If you have total 4 or 5 bottles, then it makes no sense to find the average of these 4 bottles. You can do separate for each bottle. But when it's at large, which we consider large when its total amount is more than 30, and in our case we have 50, so it is large. It makes sense to group them and get the X bar average for the entire distribution. Okay, and to show you here, by the way, you see here sigma divided square root of n. Here it is. This is where we combine and we use formula for distribution. Standard deviation, you divide by square root of total amount of meaning sample size. All right. Therefore, although A is talking about same thing, but says because the sample size is small, which is not the case, we use central limit theorem in this case because sample size is large. Now, the same thing we're going to do construct for 90%. So, which means we are going to put, everything is going to stay the same, but instead of 95, we're going to put 90%. And we are getting 0.995, 0.999. 0.995, it's rounded, and 0.999. Okay, now in this case, we are also 0.997 is falling within interval. See that? It's given, the company claims that the sample mean amount of water per 1 gallon bottle is 0.997 of gallon. And here we have, in this case, 0.999 max, which means falling within confidence interval. And answer again wrong. It says lay outside. It's not outside, within. So realistically, we can't complain. But you want to put these nonsense answers so you get your credit. But we understand, most importantly, that is 0.997 falling in the interval of confidence. All right? Okay, moving to next question. Question number 3. Why is it not possible to have 100% confidence? It's a very easy answer because when you have large sample or large population, you can always take approximate amount or interval. It's enormously difficult. Let's say if we want to find average age of population of United States, how many people we have, what's the population? Is 350 million, 400 million? I don't know, something like that. Well, good luck to go and find the age of every single of 400 million population and then find the average, add them up and divide by 400 million. This is why it's not possible to get 100% precise average. Therefore, we give confidence interval, meaning average of the sample and plus minus some error. Well, let's see. 100% confidence interval is not possible unless either the entire population is sampled, meaning what I said, questioning every single person in population, or the absurdly wide interval of estimate is provided. Okay. I'm trying to read these answers. Let me read the rest of answers and explain to you why that cannot be the case. 100% confidence interval is not possible only if the entire population is sampled. The opposite. If entire population is sampled, let's say if you have, 40 people, more than 30, and then you go and question every single one of 40, then you can get 100% confidence interval, right? Because you will have precise number of everybody. And C, 100% confidence interval is not possible only if absurdly a wide interval. No, that's complete nonsense. None of the above, it doesn't count also. So we got the answer. Moving to number 4. Okay. So, a market researcher selects a simple random sample of N N is 100, it's a sample size, users of social media website from population of over 100 million registered users. As you can see, they can't question all 100 million users. They drew sample, N is equal 100. Okay, and after analyzing the sample, she states that has 95% confidence that the mean time spent on the site per day is between 15 and 17 minutes, 57 minutes. So explain the meaning of it. So, well, it's already explained that 95% confidence that the people spend on the website between 15 and 57. Okay, which is B. Let me see what is A. Why is it not matching? Of over 100 million registered users, 95% of them spend between 15 and 57 minutes on the site per day. Now, when we are talking about confidence interval, we don't use the whole total amount of population. We just say that 95% confidence is true, that mean time of registered users spend between 15 and 57. I would say more of it, the keyword here is true. The true mean time is between 15 and 57 minutes. C, during any given day, there is 95% chance that mean time all registered users spend of the site between, no. The true mean, during any given day, the answers are very, very close to the proper answer. But this one is matching the best because it says the true mean. Because it's checked, it's calculated, it's analyzed. Okay? And the D, 95% chance that randomly selected registered user. No, this is not randomly. We don't know. Is it randomly? Yeah. Randomly selected users spend between 50 and 57. You know, to be honest with you, either one could fit, but out of these four, this one is the best because it's proper way to say on 95% confidence interval, the true mean is between this and this. The true mean, because they can claim the mean this much, but the reality is the mean located within this interval. All right, moving to question number 5. Got the whole story and all we have to do yes and no question. All right, a market researcher collects a simple random sample. Isn't it the same question here? No, this is different. Okay. A market researcher collects a simple random sample of customers from a population of over 1 million customers that has home improvement website. All right. After analyzing the sample, she stated that she has 95% confidence that the mean time customers spend on that website per day is between 18 and 50 minutes. Okay, so they created a website and from the created sample from the population over 1 million, and for them they created website, and they say that with 95% confidence they can say that mean time customers spend on that website is between 18 and 50 minutes. Suppose that population mean on the website is 37 minutes a day. So let's see which answer is correct. Does the value of population mean help to show the confidence interval? Confidence interval is correct. All right. If mean is 37 and we have 18 and 50 in the interval, 37 falling in this interval, correct? So yes, because population mean includes within confidence interval. Okay, so I'm not going to the rest. The rest cannot be similar. A is nonsense because it says is not a midpoint in confidence interval. We are not looking for midpoint. We are just looking for the number B within a confidence interval. It can be close to one border limit, can be close to the other limit. Okay, C, no, because population mean mu is not middle half. No, it doesn't have to be middle half. Like I said, it's an average, it's an interval. Mean can be anywhere. Okay, I'm moving to next question. It's the other explanations are nonsense. Excuse me. So let's see what we are doing here. Again, normal distribution. Mu average is 100. And sigma is 8. Standard deviation, sigma is 8. And given you select a sample of n16. So sample size is 16. The mean of the distribution 100 and sigma 8. Complete part A through B. What's the probability of mean that is less than 94? All right. So what we are going to do to find the probability, as you know, we need to have z-score first. So let's find out our z-score. So for a case like that, for the normal distribution, z-score is equal x bar minus mu and over sigma divided by square root of n. X bar is an average of sample, mu is an average of the population, sigma is standard deviation of population, n is a sample size. Let me write down what is where. Our mu is 100, our sigma is 8, sample size is 16. So, question. What's the population that x bar, which is a mean of sample, is less than 94? Okay. Our x bar is 94. So for that, first of all, we need to find z-score. Before we find probability of z-score that's less than, we need to find that z-score first, and then I'll put it here. So z-score is equal x bar 94 minus mu is 100. Let me see. I want to leave space. Minus 100, sigma is 8 divided by square root of 16. So what do we get here? Negative 6. 8 divided by square root of 16 is 4. And we are getting negative 6 over 2, and answer is negative 3. All right. Negative 6, sigma is 8, okay, negative 3. So the probability for z-score is less than negative 3. For that, we are going to go to the calculator. And this time is going to be this calculator. So we have negative 3 and we are getting so see, you have here x is less than z, x is greater than z, in between, or less than greater. So in our case, z is negative 3. Right here, see it's showing z is negative 3. So x is probability of x is less than negative 3. In our case, it's 0.001. Let's see what we have here. 0.0013. Okay, thank God, at least this one is correct. Actually, this one is not correct here. If I round up till 4 digits as they want, look here, this 9, I can round up, 4 will become 5, and this 5 will become 4. If they want, if they want to put around it, then it should be 0.0014. Okay? Because if this 9, if I come rounding up all these numbers, from 9 I can round here, 4 will become 5, and 5 will become here 4. And here they didn't round it, but that's all right. 0.013. Next, what's the probability that x bar is between 94 and 95 and 5? So in this case, what we're gonna do, 94 and 95 and 5. So 94 is 1, and x bar 95 and 5. For 94 we have negative 3. Now we need to calculate for 95 and 5, because we have at the interval, let me see, is it between? Yes, it is between. All right, and I'll show you in a minute. So we need to do now for 95 and 5. 95 and 5 minus 100, and I might as well divide by 2 right away, because this portion we already calculated, right? The denominator portion. Okay, it's gonna be how much? 100 minus 95 is 5. 5 minus half, 4.5. Negative 4.5. Divided by 2, we are getting negative 220. No, what am I doing? No, yeah, correct. Point, and then 2, and then 5. Negative 2.25. Okay. Let's go to our calculator. Now I'm going to choose here between, let me see. Here, left bound was how much we had? Negative 3, right? For 94, x is 94. It's negative 3. And the other one was negative, what was that? Negative 225, okay. Negative 2.25. So here it is in between. You look, x is less than negative 3, greater than negative 3, and less than negative 2.25. It's going to be, if I round, 0.011. Okay, let's go here. 0.0109. How many decimals? 4 decimals. 1, 2, 3. Okay, if I round 4 decimals, yes, 0.109. Okay, at least that one is proper. And the other one is x is above 100.6. So 100.6, you are plugging, let's say in this case, x bar, it has to be greater than 100.6. So you plug again 100.6 minus 100 divided by these 2, and we get 0.6 over 2, we get 0.3. So we put z-score, it's greater than 0.3. This is where we are going, 0.3. Okay, and click calculate. And we are choosing the one it says greater here. X is greater, z-score 0.3, x is greater than 0.3, 0.3821. Let's see, 3821. Okay. All right. There is 66% chance that x is above what value? Okay. So how are we gonna solve it? So it says there is 66% chance that x bar is above what value. So if at a 66% chance, that means the other how many, 34% is not a chance, right? So what I'm going to do 1 minus 66%. So I'm going to do either 100% minus 66%. It's gonna be 0.30, I mean, okay, it's gonna be 34%, which is decimal wise, it's gonna be 0.34. Okay, after that we are going to find what's a z-score for that. Z-score, I'm going here to z-score. So I'm going to put in this line here because 0.34, it's a 34%. That's a probability, and we're gonna get probability for 0.34. Let me put here 0.34, and I will get z-score is negative 412. See that? Z-score is negative 412. So, or you can do you don't have to subtract from 100. So because it's asking above 66%, then you put 66, meaning here 0.66, but you choose above, see, greater. X is greater than z-score. So, oops, what did I put? 66. Okay, and click calculate, and you get negative z-score negative 412. Okay, z-score negative 412. Like I said, you can use, if you use above, greater than, you can use all 66%, not a big deal. And from here, the score is given. We need to find x because it's asking for, let me see here, what's the value that will give you the 66% chance that is above of that value. So let's see if we get 9918. Let's do it. So our formula, where is it? It's right here. Okay, and let me choose, I want to choose this. Okay, it's gone. So this is our formula. So I need to find this x from here. So where is our mu? There, it's not, it wasn't complete, this formula. This is a little bit different, the formula I'm going to use. Hold on. Let me write down, clean it. Yeah. The right formula is going to be x bar is equal mu plus z score n over square root of, n over square root sigma over square root, sorry, sigma over square root of n. Okay, all right. So how much is our mu average? Our average was 100. Okay, x bar is equal 100 plus z-score is negative 0. Right, it was 0 0.414412, yeah, okay, plus, or might as well I put minus because we have negative, minus 0.412. How much is our sigma? I put here sigma 0.01. Is this from the right end? Let me see, double check my sigma. No, sigma is 8 and the sample is 16. Okay, sigma is 8 and the square root of n is 16, so it's gonna get 100 minus 0.412. Square root of 16 is 4, 8 by 4 is 2, so meaning times 2, it's gonna be 100 minus 0.824, and result is going to be 100 minus, let's see, 100 minus 0.824. This is 6, 9 minus 2 is 7, 9 minus 8 is 1. Here will be 9, and here is also 9, 99.176. All right, let me see. That's right, 99.18. Okay, question number 7. Okay. Given population of yearly sales in gallon of unleaded gasoline at the service stations located in a picture state, indicate that sampling distribution for samples of 20 would consist of. Okay, let's read the answer, proper answer. Sampling distribution is a distribution of the result of all possible samples of 20 sales figures. Because sample distribution, you get out of this 20 of every single the figure, whatever it is. What is A? Sampling distribution is a representative collection of 20 samples, each containing, okay, this is nonsense, 20 sales figures selected now. C, sampling distribution is the average. No, it's not an average. And D, the sampling distribution is a representative. No, cannot be representative. It's distribution of all 20 the sales figures. Okay, number 8. Well, number 8 I'm not going to do anymore because it's exactly same problem as we did with number 6, right? So you can look how I did number 6 and you do number 8. It's the same question. Okay, and last question, number 9. Okay, this is not. I'm going to stop this and then record a separate question number 9. All right. I got question number 9. Yeah, that's green. That's okay. So question number 9, what do we have? In a random sample of 60 people, 45 are classified as successful. So determine sample proportion. Okay. Total N is 60 and X selected is 45. This is N. Proportion. Proportion, we need to find proportion between them. What's how many percent is selected? How many percent is selected? 45 over 60. Let's reduce by 5 is 9. Reduced by 5 is 12, right? And then reduced by 3 is 3. Reduced by 3 is 4. 3 over 4, which is 0.75%. Okay, 0.75. So let's see the answer. There we go, 0.75. Now, in the next one, we need to find if the population proportion is 0.65, determine standard error of the proportion. Okay, its proportion is 0.65. Find the standard error of proportion. So 0.65, we need to find standard error of this proportion. So standard error it's equal of proportion is equal proportion times 1 minus proportion and divided by N, which is in our case it's gonna be square root 0.65 times 1 minus 0.65 and divide, our sample size was how many? 60, yeah. Here we got here 60. So let's see. Square root 1 minus 0.65 is gonna be 0.35. So 0.65 times 0.35, I got 0.2275, and if I take square root, let me see, I can't shake it, so take it, square root of 2275. My calculator is not showing. Okay, let me use different calculator. Let me find square root. No, I can't find it. In my phone, it doesn't turn horizontally. So bottom line is you're gonna get square root of 0.2275 and divided by 60. I can go backwards since I can't get it. That's crazy. Okay, let me do it this way. So the answer is 0.0616. So 0.0616. I'm going backwards times 60. I should get 0.2275. No, square, I should get the number that square root of square will be 0.225. Let me see. 0.0616 times 60. I'm getting 3.696. Oh, and again, yeah, I have to take square root. Well, my calculator is not working, so you can take the square root and you should get here the answer 0.0616. Okay, that's the bottom line, guys. Okie dokie, we are done, and I'll see you in next homework.